Yeah, let's just do these two. They are the ones that have proved to be really challenging, and it is those challenging ones that sharpen our brain to be a seriously good problem solver. You would have survived these challenging questions. So count it joy when you are tested using these challenging questions, because pressure makes diamonds. Yeah, even those roses that we buy on Valentine's Day, for you to experience their beautiful scent, it has to be squashed and crushed. So these questions will bring out the best out of us. Let's see if we can survive it. Starting with question number 10. These are identities. So remember, in identities, we have to simplify the left-hand side until it looks exactly like the right-hand side. Or sometimes we simplify the right-hand side until it looks exactly like the left-hand side. Or sometimes, like in this case, you have to simplify both sides separately until they look exactly the same, and then we can say we've proved the identity. Let's deal with the left hand side. I'm going to start with here. Left hand side is equal to sin A minus tan A all over sin A plus tan A. When we are dealing with identities, you should remember this tan A with the replace tan A with the identity sin A over cos A. So this is sin A minus okay, minus sin A over tan A. This is all over. It's the same. The difference here is the sign only. So it's also sin A plus sin A over, not what am I writing here? This is not true. Okay, it's sin A over cos A. Where am I getting this? It's Friday night. It's Saturday night. Yeah, sin A over cos A over cos A. There we are. And then we want to put these two together, making use of a common denominator. So we have sin A minus sin A over cos A, and this is over 1. So our common denominator there should be cos A, and then on top we have sin A by cos A, so it's sin A cos A, and then minus 1 times this sin A, so it's minus sin A. There we are. So this is equal to, I'm going to write it here, this is sin A cos A minus sin A all over cos A. This is the numerator, and then we bring in the denominator. Now I'm using the red color there to make sure we see the difference between the numerator and the denominator. My denominator is exactly the same as the numerator. The difference is the signs. So this is also going to be sin A cos A minus, no, plus. The denominator has a plus, so it's plus sin A all over cos A. And then from there, hey, okay, let me clear my space here. From there, I want to remind you of the addition and subtraction of fractions. If we have A plus B, no, not addition and subtraction, division. A plus B divided by C over B is A over B divided by C over B. Now this one is A over B multiplied by. When you change to multiplication, you flip this one to be b over c. You invert it. Use its reciprocal. Remember, the reciprocal of division is multiplication. So if we are dividing by this, is the same as multiplying by its reciprocal. Now, once we have something like this, it means we are now cancelling this b and this b. We are left with a over c. We have exactly the same thing here. Our denominators are the same. The denominators here is cos a and cos a. So we are going to flip that, and then we have the first one cos a will be on the denominator, the second one cos a will be on the numerator. We cancel those cos a's. Right, let me just write it here. So we have sin a cos a minus sin a all over cos a. It's division, so we can change it to multiplication just like we did here. We flip this one to have on top cos a all over sin a cos a plus sin a, and then from there we have this cancels with that, so we are left with sin a cos a minus sin a, that is the numerator, and then the denominator there is the one that has a plus there. It's sin a cos a plus sin a, and then from there we have a common factor on the numerator, that is sin a bracket cos a minus 1, and then on the denominator we also have a common denominator there, I mean a common factor. It's sin a bracket cos a, this is plus 1, and then from there we cancel sin a and sin a, and what we are left with now, uh, what we are left with now is cos a minus 1 over cos a plus 1. So we are saying our left hand side there, we saw that is cos a minus 1 all over cos a plus 1. There's no simplification that we can do further than this. Now, I'm writing it here so that I create space here. Then I do the right hand side there. Okay. This is now the right hand side, my right hand side. Now we're still here. It's now the right hand side, this one here. Is going to be equal to, all right. Now remember we have 3 expansions for cos 2a. But which one can we choose? We should choose the one that's going to make our life easier. On the denominator, we have only one ratio, that is cos A. Even the left hand side, there is cos A only. So it means of the 3 that we are supposed to choose here, we choose the one that has cos only, and is going to be 2 cos A squared minus 1. So that is cos 2a, and then we have a minus 1 again, that minus 1, and this is all over. There's nothing we have to do now on this one. 2 cos a plus 1 and then squared. From there, this is now equal to, on top is 2 cos a squared minus 2 over 2 bracket cos a plus 1 squared. Now, on top you see we have a common factor 2, and then on the denominator that 2 has been factored out. So we can then factor out of the numerator to have 2 on top is cos a squared minus 1 all over 2 cos a plus 1, and this is squared here. And then from there, we have cos a plus 1, which is squared. So there is 2 brackets there. There is 2. I don't have to write that 2. I really don't have to write it. My red pen there. Cancel, cancel. And then we can continue. So on top we have cos 2, cos a squared minus 1. This is a difference of 2 squares. We have to write it, we have to expand it so that we have the same as what we have here, that is 2 brackets. So on the denominator is cos A plus 1 and another cos A plus 1 because it is squared. And on the numerator there is difference of 2 squares dots, which is bracket cos A plus 1 and cos A minus 1. All right, and then from there, we have to cancel also. We have cos A plus 1, we have cos A plus 1. So then we are left with cos A minus 1 all over cos A plus 1, which is equal to our left hand side. Remember, this is the right hand side. So we are saying right hand side is equal to left hand side. All right. That is all for the first question. You can go back, start it afresh, watch it so that you see all the tricks that are involved there. That was a very interesting question, thought-provoking question, one that demands for the use of that matter that was put between our ears. Now this one it looks even more interesting. Okay, let me start with the right hand side. It's friendlier on the right hand side. So my right hand side is equal to, let me use blue. Blue is friendlier. Is equal to, there's tan A plus 1, tan A plus 3. I want to replace these with the identity there. So it's sin A over cos A, and then it's plus 1 all over sin A over cos A plus 3. And then from there, we do what we did in the previous question. Common denominator here. Our common denominator is going to be cos A, right? Common denominator for the numerator only is cos A all over is sin A, right? Plus cos A, sin A plus cos A, and then the big dividing line, then we write the denominator there. We are doing the same for the denominator, just that it has a 3 there, so it's over 1. Our common denominator there is cos A once again, and then this is going to be sin A times this one, which is sin A, and then 3 by this cos, so it's plus 3 cos A. And then the trick that we used that time, but we are dividing this, we are dividing by this, so we can multiply by the inverse of this one, I mean the reciprocal of this one, by flipping it. The cos will be on top, this cos is below, they cancel each other, so that we have sin A plus cos A all over, this will be our denominator there, sin A plus 3 cos A. If you did not get that one, go to the previous question. So this is our right hand side. There is nothing else that we can do here. Let me write it here. My right hand side is equal to sin A plus cos A all over sin A plus 3 cos A. And then let me go to the left hand side, which is looking scary there. My left hand side. What am I going to do to this left hand side? So cos 2a cos 2a all over this whole thing here. How are we going to do it? Now, looking at the right hand side that we have simplified, we can see we have both sin A and cos A, right? So I think for this side here, we are going to choose the expansion that is including sin A and cos A there. That one I think is going to give us what we have on the right hand side. And then on the denominator, how are we going to, because we have sin A cos A on top, sin A cos A on the denominator also, how are we going to bring in the cos here? There is a little trick that we have to use there, making use of the square identity. So the numerator we are saying is cos A squared minus sin A squared. That is the other expansion there. And then on the denominator, we remember our square identity, sin A squared plus cos A squared is equal to 1. These three here, there is a 3 times 1 there, right? And then the moment we bring in that 3 times 1, we are going to have what we have. Look at what we have here. That's 3 times cos A. So I think it's going to give us what we are supposed to get. So this 3 times 1, I'm going to write it as 3 multiplied by, instead of writing the 1, I'm now writing what is equivalent to that one, the square identity. So in bracket, it's sin A squared plus cos A squared, close that. And then we come to this one here, minus sin 2A minus 4 sin A squared. Now, I see we are going to get what we want to get there. We're going to get some kind of a quadratic trinomial there. I remember seeing such, factorizing such in grade 10. So this is cos A squared minus sin A squared. And then let's deal with the numerator there. I mean the denominator. Clear this bracket is 3 sin A squared plus 3 cos A squared. And then let's expand here. Minus 2 sin A cos A, our double angle formula there, and then minus 4 sin A squared. And then the next step, that is equal to cos A squared minus sin A squared all over. This is 3 sin A squared. This is minus 4 sin A squared, right? So I'm going to take that. Let me start with 3 cos A squared minus 2 sin A cos A, and then 3 sin A squared minus 4 sin A squared. It's minus 1 sin A squared. All right, there we are. Now, there we are with the trinomial that I was talking about. We have a trinomial that looks like this. Is 3a squared plus or minus 2ab and then minus a squared. Do you remember factorizing trinomials of this nature? It's going to be 2 there, and then we have a and b in those two brackets. It's going to be 3a, it's going to be a here, there's a b, there's a b, and then our signs, when we have a negative here, it means we have two signs which are different in the two brackets. So the other one is positive, the other one is negative, and then I'm going to have, if I have positive here, and then I have negative here. Okay, I'm saying this is B, not A. This is B. So this is going to give me negative B squared, and then the first ones will give me positive that, and then just verifying my expansion there. I sometimes make mistakes. This is 3a squared minus 3ab, and then plus ab minus b squared. Okay, that is right. And then when we subtract, it gives us negative 2. So what I'm saying here is my a is my cos and my b is my sin. So when we factorize this whole thing here, we are going to have, let's also factorize the numerator. This is difference of two squares. So this is cos a plus sin a, and then cos a minus sin a. That is dots for the numerator. And then the denominator, I said it looks like this, where my a is the cos and my b is the sin there. And then factorizing that thing, we have these two brackets here. That is uh, all over 3 cos a plus sin a, and then bracket is now a minus b, that is cos minus sin. So this is cos a minus sin a. And then what is left? It's just cancelling there. It's a matter of cancelling this cos a minus sin a, cos a minus sin a, and look at what we have there on the numerator and denominator. This side, our right hand side, is sin a plus cos a. Here we have cos a plus sin a. That is the same. And then here we have sin a plus 3 cos a, and here we have 3 cos a plus sin a. That is the same. So I'm saying, yeah, therefore, my right hand side is equal to my left hand side. All right, that was an adventure.